So most of my in my study, most of it I use Homer software. Okay, this software is okay. I'll brief the software later. So I use the software to analyze and simulate the potential of producing hydrogen using the surplus energy from a potential hydroelectric plant. Okay, and I will use this. I've used this software to validate the theoretical hydrogen production rate that range between 150 to 160 kg per hour. So a brief introduction on Homer software. It is developed by the National Renewable Energy Laboratory, USA. It's a free software, so it can be downloaded by anyone. Before starting the simulation, user specifies the components to consider and together with its input details. And after that, Homer will do energy balance. Okay. So first, Homer will compute how much electrical energy is available, and then it will compare it with the hourly demand, which is also specified by the user. And then, if the system is found to be feasible, the system will be listed in the optimization result window, and they will be ranked according to which one is the most economical on top. And if the system is not feasible, Homer software will just discard it. There were 3 major simulations that were made. The first one simulate the current power generation, which is the diesel generator. And then second one looks at the feasible 12.9 megawatt hydroelectric. And the final one look at the simulation of the proposed system. Okay, I will skip the first 2. Okay, I will brief you on this, the proposed system. So the components that I considered was the 12.9 megawatt hydroelectric, the current diesel generators, the 2007 demand, electrolyzer, and hydrogen production. The simulation were made 2 times based on 2 scenarios. First scenario involved in the water discharge from the dam, which is 27 meters cubed per second, which is the annual average of the Temburong River. And the other one, the second scenario, I use the water discharge rate from the dam, which is equivalent to the monthly average of the Temburong River. So the purpose of this simulation, okay, is to see whether it is feasible to produce the hydrogen at a constant rate. I also would like to see the economics of this process and also the emissions involved. Okay, I'll skip this. Right, so this is the results. It is possible. If you look for scenario 1, we can produce more because a larger electrolyzer capacity can be used. This is due to the water discharge rate, which is constant throughout the year. Okay, the discussion. So, if we switch the diesel generator to hydroelectric power station, it is possible that there will be a cost of energy production reduction between what is equivalent to 20 cent Brunei to 12 cents Brunei. There will be a reduction in carbon and other greenhouse gas emission. And there will be a potential of saving 10 million liters of diesel per year. The CO2 savings, CO2 emission savings that could be achieved is around 27,000 tons per year. This is equivalent to removing 5,583 cars from the road. Okay, so for the proposed system, okay, it is only possible to produce 116 compared to 150 calculated theoretically. This is because I model, or my target is to look at a constant rate. Okay, it is possible to produce 150, but it will not be produced constantly. Okay, since we are running out of time, I'll just move on to my conclusion. So switching to hydroelectric power generation in Temburong will bring both economic and environmental benefits to the country. Hydrogen production using the excess power is possible. Okay, and hydrogen production could result in further emission savings if it will be utilized properly in the later stage. Okay, so I'll conclude my presentation.